Hello developers, let's start developing. My name is Veko and we're gonna take a look at the 2022 Advent of Code Day 18, Part 2. So, to do a quick recap, we are outside, some lava droplets are falling, and we need to see what is the surface area of all the lava droplets that are falling together. In the first part, we did exactly that. What is the exposed surface area, but now we need to see what is the external exposed surface area because we might have cases like in a two-dimensional way. For example, this thing is exposed, but it's not exposed to the outside world since it is an enclosed thingy. So, first of all, I have no idea how the solving of this will go, but I have a weird feeling about this. So this is the full input. It's about 2800 lines or 2023 lines in this case. I have checked it with a few different inputs. And let's see what is the bounding cube, not the bounding rectangle. Which means let's take a look at what are the minimum and maximum in each of the coordinate systems. So let's see what is the min x. That's Yeah, that's the minimum X point, the maximal X point. Yeah, this is GitHub Copilot at its best, and let's just do a console log of all of them. Let's see what is our bounding cube for this. So it turns out that our minimum is 0, maximum is 19, minimum is 1, maximum 19, minimum is 0, maximum is 19. Which means a 20 times 20 times 20 box will cover everything. And 20 times 20 times 20 is not so much. 20 times 20 times 20 times 20 times 20, it's 8,000 cubes total. So for 8,000 cubes, I think that we can do a flood fill. Just a simple flood fill. I don't think that we have a case. What are the zeros? Those are the interesting ones. Let's see whether we have the 0, but not as a 10, but as a just a 0. So we have 990. Yeah, that's one. And let's see, comma 0, but not 1. I don't want to write regexes, so we will do a bit of searching. Yeah, we have 0, 10, 10. What did we do with this last time? Oh no, we took all the pairs, and since this doesn't have anything. But I have an issue with zeros because we don't have a 0.0. Let's just see. 0.0, comma 0, comma 0, comma 0. Yeah. So the origin is not in our scope. So let's make a 3D matrix out of this. We don't need this, but let's have it. So yeah, let's call it all space. That's an array dot from or yeah, just do an array of something like this. So are we using this anywhere? And we're mapping and we're filling and we're mapping and we're filling. No, I don't want it flat. So now all space will be a simple an array of points. Do I want it like this or do I want it like a proper matrix? If we just stop it here, and let's remove the main X, Y's. So this is trying to take me to a different way, and that might be a good thing, but let's not do that at the moment. Which means that I can replace all of this with just an underscore, because I don't care about the value, and this an underscore because I don't really care about the value. And now all space, yeah, it's a number array. And I can say for, yeah, each of the cubes that we already have, put in 1,000. So each cube that is covered by a lava droplet is 1,000. Next, what we would like to do is to basically start some kind of a flat fill. Yeah, turns out we don't need this. For now, if we need them, we'll return them. Yeah. We're gonna put in a point that says x, y, z, 0 inside a q. Well, the q is bigger than 0. We are getting the current. We don't care about the current distance, but this is the thing that this is in the right direction. So we're gonna take an item and set it as passed. So we're gonna say all space of, it's not 1,000, it's 1. So 1 means there is steam in that place, and 1,000 means there is lava in that place. It could have been 2, but I have arbitrarily set it to 1,000. And now take all of the neighbors. Some of these will be outside of the array. So can we do this and this? No. So we can just say, yeah, we can just ignore all that. So we can say if current.x, yeah, that long thing is some of that is out of scope. Thank you. We're not doing anything. Otherwise, get all the neighbors and basically add them to the queue. If and only if they are no unknown. Yeah, so this will run through all of the fields. Let's try this with the smaller input, which has a 5 by 5 by 5 set. And let's see what do we get. And after this, let's say just console log all space. This is gonna be a 6 by 6 by 6, a lot of points, but we can see cannot read. Yeah, we need to check it. Since we're already checking it, we need to check it before we push it here. Yeah, it suggested a different thing. Yeah, let's have it like this. This looks a bit better. And I think that everybody can see what is happening. If it's out of bounds in the Y or the Z or the X direction, it's out of bounds. We're not doing anything. So this should work. And you can see what happened with our flat fill. Lots of ones, lots of ones. Oh, we have a lava here. And here we have our single point that is inside something. So we're gonna do something else now. We're just gonna do a simple for loop. All space, and this is not an, this is our X index. So this is not an element, this is an X plane. This is the whole two-dimensional matrix, and we're gonna run again. So this is not a Y plane, because if we set the X and the Y on a given thing, we are left with a Y line on the Y. So we have Z index, and we don't want to have a Z plane, and we're just gonna say if, yeah, that's the Z point. If Z point is 0, then just console log the X index, Y index, and Z index. And we can just say 0 at. Yeah, we have a 0 at 225. And we can see that this is actually correct, that the point at 225 is inside. Let's just see how many of those points we get for this. And I'm quite concerned whether we missed some. Ooh, this is taking some time. Way more than I expected. Okay, let's kill this and add some debugging things to see what is happening. We're setting it to 1. We're calculating the neighbors. We're just adding all those neighbors. So unless, and it goes well for all of the values that are here. So yeah, Let's print out the current total. Yeah, and that's the Q. Let's see what happens with that when we have the small input. 13 points. Maybe there's something that I'm not seeing because we're just should be spreading out everything and we have 8,000 points at the very best. Current is 336, current is 336, current is 336. How is it possible that we are processing 336 a lot? And we have 6 times 6 times 6, that is 216. It is quite weird if we get a queue of a lot of items. 336. What is so magical about 336? Yeah, we're only adding it here and we're only processing it here. But we might add a single neighbor multiple times. I'm still not clear on why 336 was put in these many times. I don't think that's... Oh, 336 is the last point. Why? I don't get it. To be honest, I don't get it. Which means that we get to debug. Because I have some kind of a weird error somewhere. I know one of the reasons that we can have a lot of points that were added multiple times. And that means that we're gonna add their methods multiple times and so on. So we can just say if this is not already passed, actually if this is already passed, go on. For a second, let's just see what this does. This looks more like it. Yeah, we did protest 336 a few times, but if I put it here, we're gonna protest it just once. It says total QS2, and after that we just did it. Will this work with the huge array? Yeah, it does. And we did get some zeros. That's great. So yeah, that was the bug, because if we are adding something, we can add a thing from multiple directions. So everybody is adding everything and we are just setting it and adding their neighbors again and again and again and again, and this thing explodes. So if we remove this console log, yeah, it basically runs immediately. And if we remove this console log, we can see how long it actually takes. Yeah, basically no time at all. I'm gonna do a bit of a hack. Just give me the zeros for x on the zero plane. because there are a lot of zeros. So there are no zeros on the zero plane. Let's see if there are any zeros on the one plane. No. Okay. And there are several zeros at the two plane. Okay. That was one of the things that I was worried about. Do you know why I'm worried about these things? Because if we have points that are right next to our thing. So for example, this is our origin, 0, 0. And we have some boxes that are spaced out like this. This is available from the outside. Basically, you can get to it from here. So Steam will bring here, will come here. But uh, if we do a flat fill and we say we have a 3 by 3, when we do a flat fill, we will just cover this and then this and then this and then this and then this, and we're gonna stop because we are, this is the maximum index, this is index 0 and 1, and when I said made us a 2 array. Yay, so let's count the 0. And let's log. Let's see how many zeros there are total. 1108. And what happens if I widen the array a bit? So it's plus 2, plus 2, plus 2. Of course. How could there be more zeros now after we've done this? So it seems that I have a bug in my visualization. On the other hand, just a sec. Let's have it with the larger value. Yeah, we should just get a single zero. And says that we have 89 zeros. Well, that's more than one, which means that unless running to max x, yeah, this is the actual limit that we want to take care of. Our maximums are now one off. Let's see. Yeah, we have a single zero. What does this mean? That instead of having this bounding rectangle, we initially, if just I'm explaining this as it was is a plane. Basically, in 3 dimensions, we only have one more dimension. So we initially took this bounding rectangle, we started the flat fill and filled those. Now we're taking this bounding rectangle and not this. And let's see what happens when we do flat fill now. Now we can fill this, this, and we filled these parts, which were part, we filled this. This was part of the old bounding rectangle, but it wasn't filled because there was just no way to get to it. Now, since we have zeros, it is possible to have this. So in order to avoid that, we would have to do something like this. Add a row and add a column, and then if we do a flat fill from here, we're just gonna fill everything. this will get filled, and of course this will get filled as well. So in order to do it properly, we would need a flooding uh, flood fill for a larger bounding rectangle on all sides. But the issue is that I didn't really want to do the zero offset. So in order to check that, I will return to the larger input and see. Before we had 1008 and now again we have 1008. So at least I don't think that we have any zeros on, and we don't have such a case because the minimum x was 0, minimum y was 1, minimum z was 0. So we don't have anything that touches this on the y plane, but we have things that are happening on the x and on the z. So that's why I wanted to see how many zeros we get when we basically hard code x to be 1, which is 1 0, which is 0 zeros. If it's 0 zeros, that means that we don't have such a case. And run all the 0 indexes on the z plane. And we don't have any zeros there, so I'm quite certain that we don't have such a case. So we have that many zeros. Let's just bring this back, the small input. So now we can have our zeros instead of a count to be an array of all the actual zeros. And we're just gonna say zeros dot push. Well, that thing, the key. Do we want to do that? Maybe a set would be better. Yeah, let's have it as a set. And we're just adding the key and we don't even need the parentheses. That is okay. So now if we just console log the zeros, we should get a 2 to 5. Yeah, it's a set with an element called 2 to 5. Okay. Now we just need to get all the, we will just redo this. We have all the zeros in our input. We have all the places which are unreachable by Steam. Now, we need to see uh, how many of our sides are not connected to another cube and not connected to a cube that's also that's also not reachable by Steam, because those are the interesting. In order to do that, I will kinda refactor this. So this won't have a side sting. It might have it. We might want it to be a bit better to have 6 booleans. So we're gonna have a top that's gonna be boolean. We're gonna have bottom that's gonna be a boolean, a left, a right, a front, and a back. So we have 6 booleans. Initially, for each of these things, we're just gonna say Front is true, back is true, left is true, right is true, top is true, bottom is true. All of these are covered. Otherwise, so we're gonna get to the looping of our cubes, and now we're gonna do some worse conditions. So we're gonna say if we need to take care of the different orientations. So it's gonna be something like this. If first equals, if they have equal x's and equal y's and is exactly 1. So if we have x going that way, y going that way, and z going that way, that means the first has as one larger z, which means the first is on top of the second one. So the first one's bottom is covered and the second one's we don't have second sides. Of course we should have second sides. It's this one. Not there. There. Second side's top is covered. Not else, but else if our difference is -1, then they are exactly the other way around. The first one is on the bottom of the second one, so the second one's bottom is covered and the first one's bottom top is covered. Otherwise, no change. If there are two, if the difference in z is 2 or more, we don't really care. So this is same x and y, and this is same x and z, which means that we need to have, okay, I will delete this and hope that yes. Okay, this can be an else if. Yeah. So this, I said initially that it's gonna be ugly, but let's check it once more. So if the x and the z are the same, so that is the same, that is the same, so we have, yeah, okay, if we have this x and this z, so we're going back and front, not top and bottom. Okay, and if y and z are the same, that's the same, then we have left and right. Yeah, 3 dimensions are kind of hard to think about. But since we are already processing this, for each of the cubes that we are running, we can also check whether our front, back, left, right, top and bottom are connecting to a 0. So we can say what is the key of our top. So for the top, we just increase the z. For the bottom, we decrease the z, left, right, front, back. Are those the correct? It doesn't really matter if those are the correct decisions. So now we can check for each of these if zeros has that. If the zeros have that value, that means that our side is not open. Our side is not connected to any kind of other lava droplet, since it's connected to a zero, but it's connected to something that doesn't have a stream. Yeah. So this was much simpler, but also less detailed. So after this, we have our droplets collection. Let's just log it. And I hope that we have the small input. Yes, we do. We have our regular, and you can see that this one is covered on all sides, this one is covered on 5 sides, and so on and so forth. And this is the interesting one. 225 is the one above it. And before we had that this was open on 5 sides. It was open on the top as well, because the top looks on 225. But now it says that bottom is not covered, because it's 223 is also there, but the top is not covered as well. 226 was counted as a full 6, because it was not connecting to any other droplets, but it's connected to the 0 at 225. So this is a false, which means that now if we just say droplets dot values, get the values of the droplets, put them into an array, and now we will need to map each value, and now each value has 6 booleans. That is the sides, and we will need to map them to. Is there a smart way to get one from a true? JavaScript is sometimes funny. What is the value of true? It's that. And what is the value of plus true? It's exactly 1. What is the value of plus false? It's exactly 0. So if we have true plus false, we will get that. And if we have true plus true, we will get that. So this means if we have 0, 0 plus true plus false, this just returns what we want it to. So we just run a sum. Yeah, so we can just sum the sum. And that's our result. Yeah, so this is a terribly inefficient and ugly code. But, oh, of course, I cannot just sum it because this is an object. I will have to deconstruct it into an array. So this is actually a object that has front, back, oh, I need another set of parentheses here, I think. Yep. So now this will just sum the front and the back, but we have other properties here, and those properties are bottom and left, and the order doesn't really matter. And top, we're just putting them here in basically any order. Left, right, top, and bottom. And then we are summing over that array. Yeah, this looks extremely weird. And at the very least, I would extract this something to a method that's called something like bitmap to array or bitmap to sum or bitmap to something. But we got 58, which is the value that we were supposed to get. So, as much as it pains me to say it, you can't argue with results. Let's see if this actually does something. It ran for over a minute, but it gave us an answer that kind of feels correct. Let's see if that is the correct answer. Otherwise, we will have to continue on. But that's the right answer. And this is an extremely inefficient way to solve this. I think that one of the ways that we could solve it better is to have some kind of an analysis. Yes, maybe something including flat fill, but basically because there is a limited number of areas of cubes that are connected to our basically to our droplets. We can analyze only those and do some kind of fast and easy analysis. Brute force is not suited to this. One way that brute force wouldn't have worked very well or at all was if the range was not 0 to 19 but 0 to 10,000. Because again, 20 times 20 times 10, 20 is 8,000, but it was 10,000 times 10,000 times 10,000, that would have been a trillion. And that's a huge number. On the other hand, usually advent of code tasks, when the author didn't want them to be brute forceable, he will put that inside the input and we would have to use some kind of a smart method. So the lesson that we can take from this is know your input. That's extremely important because even an ultra slow algorithm like this one, when we are basically doing a flat fill on the whole volume, and that goes up with the cube of the size of the input, not the size of the input, of the size of the values of the input, would have been impossible to have it running for any other kind of input. But for this specific input, this worked. Not too fast, to be honest. This is still a significant amount of time, so I might optimize it. But on the other hand, we did get the correct answer. So that's it from me. See you tomorrow. Don't forget to like and subscribe.